going to name this is cyclohexane. Okay. This compound has a substituent which is a methyl group. So this, I'm going to call it methyl cyclohexane. Now this has two substituents. One is an ethyl group, 2 carbons right here, and this is a methyl group. Now the ethyl group, the name starts with E. This one, the name starts with M. E comes before M. So I'm going to start the numbering from here. 1, 2, 3, 4. So this comes before this. So I'm going to call this 1 dash ethyl dash 4 methyl cyclo. I'm going to change the structure. Let me erase it and let me draw a different structure. We have 3 different substituents on a cyclohexane. We have a methyl group, we have an ethyl group, and we have chlorine. Naming this, you can start by saying already chlorine starts with C, so let's start here with the numbering. Okay, so if I start here, I'm going to count 1 for this one, 2, 3 for the ethyl, and then I have to go all the way here. So 1, 2, 3, 4, 5, 6. So I'm going to say that this is 1, 6 methyl. So we can also start from here, it's carbon number 1, then count from here to here. So 1, 2, 3, 4. So over here the chlorine will be our carbon number 2 if you set this as our starting point. So you get 2 chloro. And then this will be number 4 now. So 4 ethyl, then 1 methyl cyclohexane. That's another possibility. Now the other possibility is also looking at the ethyl group, and then say we're going to start counting from here and go this way. Okay, that means this will be a carbon number 1, then number 2, number 3, 4. So the chlorine will become a carbon number 3. This will be carbon number 4. This will be carbon number 1. 3 1 ethyl. Okay, let's choose only route from here up to here, or here up to here, because if you choose from here going this way, it will be just, the numbers will be too huge. So I just ignore everything on the side and then count. Start counting from here to here, from here to here. Yep. So we have 3 different possible names. Which one do we choose? Obviously we have to look for one with the smallest sum of the numbers as possible. So let's come here. If you sum 3, write it properly. 3 plus 1 plus 4 gives me 8. Okay. I come from here. 1 plus 3 plus 6 gives me 10. I count from here. 2 plus 4 plus 1 gives me 7. So that means this gives me the smallest summation, and therefore this is the correct answer. These are discarded. So that's the correct name of this compound, is 2-chloro-4-ethyl 1-methyl-cyclohexane. Looks tricky, but you just have to inspect the structure. Okay, let's name this 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So parenting is octane. And it's coming off of here, this A-type group. So this is from here 1, 2, 3, 4. So it's 4. If you start from here 1, 2, 3, 4, 5, you'll get 5 instead, and we don't want this. So this is what we want. Step so you get the smallest number as possible. Now I'm going to change this and put a substituent on a substituent. That can complicate the naming, but we can still name it. Okay. We have our octane as our parent chain, right? Octane. But we have an ethyl group. This ethyl group is coming off of carbon number 4. Okay. However, the first carbon on the ethyl group that's coming off of the main chain has a substituent on it, which is chlorine. So you have to take that into consideration. So this should be named as 4-, and because this is a substituent of the substituent, the naming of this is usually put into brackets to specify the position of the chlorine on the ethyl group. You're going to put into bracket this. Now this is 1-chloro-ethyl. So it's the brackets. Okay. So it is telling me that I have ethyl substituent coming off of carbon number 4 on the octane, and then the first carbon that is joining the branch has a chlorine coming off of it. So that's why this is number 1. That's the first carbon of the substituent ethyl group having chlorine. So that's why this is 4, means that this is on position 4 here. And then 1 here means that the HR group, the first carbon, is having chlorine. So this is the proper name of this compound, 4 to bracket 1 chloroethyl. Then the main name is octane. Okay, I'm going to change the structure. Cyclopropane is attached on carbon number 4 of the octane. So that's how it looks like. There's not much to do here. The first carbon on the cyclopropane is attached to carbon number 4 of the octane. The cyclopropane take the last name. Say put bromine right here. Now over here the bromine is tied to the cyclopropane and the octane is tied to the cyclopropane at carbon number 2 of the cyclopropane. The naming will be 1 bromo 2 to bracket 4 octyl cyclopropane, because we started counting from the bromine and then went the other way. So the octane, which is now the substituent, is attached to carbon number 2 of the cyclopropane. And the carbon number 4 of the octane is attached to the cyclopropane. Alright, different compounds. So this is cyclohexane and this is cyclopentane. Now obviously cyclohexane is a bigger ring than cyclopentane. So we're going to take this as our parent and write cyclohexane. Okay, that means this will be our substituent. So this will be cyclopen. So the name of this compound will be cyclopentyl cyclohexane. Okay, so that's the name of this compound. The larger ring will take the parent's name. Okay, how if I put another substituent here? Then the name is going to change. So that's the largest ring. So we're going to use this as a parent name, which is cyclo. Now we have cyclopropane, cyclopentane. We can start numbering from here because we have two substituents. We can choose any of them to start our number. So let's say we start from here. 1, 2, 3. Okay. So I'm going to write 1 dash cyclo into dash 3 dash cyclo propyl cyclohexane. Okay. Now I don't want to go through this route because if I count 1, 2, 3, 4, 5, this will be 1 and 5. So obviously 1 and 5 is bigger than 1 and 3. So I don't want to use this route. I have to use this route. So this is preferred. Okay. If I start counting from here, to be 1, 2, 3. Now if I do that, I'll have instead if I use this as my starting counting 1, 2, 3, I'm going to get 3 here, then I'm going to get 1 here. Okay, the naming should be the same, but the numbers are going to switch. Okay, we want the smallest number to start, so this is still more preferable, and this you're going to discard this. We don't want to go through this route because this will give us bigger numbers. So this obviously is the case. Okay. Now let me change the structure slightly. Let me put it's got 4 different substituents. So we have 3 parts of the ring that are having substituents. So that means that we have basically 6 ways of naming this compound. Okay, so we can start from here and name it. That means this, if this carbon number 1, we have 1, 2, 3, 4, 5, 6. So now this metal group is pentyl and it's propyl. So M comes before P. So I'm going to start with this. If you start with this carbon number 1, 2, 3, 4, 5, 6. Then this will be carbon number 1, 2, 3, 4, 5. So we have 5. So we have 2 of them. So just the usual one. 1, 2, 3. Okay, that's using this and counting from here up to here. Okay, you can also count from here up to here, which is 1, 2, 3, 4, 4, 5. In that case, you're going to get 3. Okay. So choose this. So I'll start in compound. Then we can start from here. 1, 2, 3, 4, 5. So we're going to get then we can also go from here to this route. So 1, 2, 3. So in that case, we're going to get 3, 3. Okay, so let's use this. Let's use this. That'll give us 1. Oh, this is number 1 right now. Can go here or here. So let's go with this route. 1, 2, 3, 4, 5. 1, 1. So it's actually carbon 1. So 1, 2, 3, 4, 5. That's going from here to here. Let's go from here to here. 1, 2, 3, 4, 5. That'll give us 1, 1 again. Let's try now. Until 1, 2, 3, 4, 5. Okay. So right now we have 6. Now which one do we choose? Just let's inspect the normal combinations. So we have 1 plus 1 plus 3 plus 5. This will give us 10. This is 1 plus 1. 5, 10. This 5 plus 5 is 10. Plus 3 plus 1 is 14. 3 plus 5 plus 1. 12. This is 10 plus 1 is 11 plus 3, this is 14. 3 plus 1, so 7 plus 5 is 12. Okay, so we're going to route all this and just concentrate on these 2 guys right here. This is more preferable because 3 comes before 5. So we're going to choose this as our answer. Yep. Even though this is also correct, but we want the numbers to follow certain order. Smallest comes before the biggest number. In this case, there is a bigger number for the smallest number. So, having checked all the possibilities, this is the proper name, and therefore we are going to discard this one. Okay, so I wanted to summarize the nomenclature for naming alkanes. This is also similar to every other functional group. So looking at all this, there is an easier way. These steps are all fine, but sometimes you can work faster, especially in this case by just looking at the names of the substituents and then just arranging them in alphabetical order, and then just starting the count from the substituent that has the name that comes first. So like from metal, you're going to pental, then you're going to propyl. In this case, you can get the answer much quicker. Let me summarize the naming. So you start by looking for longest. Carbon chain, which will obviously be the parent name, and second step, maybe you can look for substituent. This could be alkyl groups or other groups. And then thirdly, you can name and arrange substituent in alphabetical order. And then the fourth one can use numbers. Commas, and dashes. And then other things like ignore, prefixes, samples, like try, cyclo. Just go with the names in alphabetical order. The di, tri, cyclo, and other things do not affect the alphabetical order. Yeah. There are other ways of naming things, but these are just basic ways that can help you get the names, at least most of the names in organic chemistry. And this naming, as I said, goes for alkanes. However, if you do alkenes and alkynes and other functional groups, you will see that this also comes into play, follows basically the same order.